Hello and welcome to our next lesson on trigonometric ratios. Today we are looking at both the inverse trig function as well as applications of the Pythagorean theorem and trigonometric ratios. So in our previous lesson, you saw how we were able to use trigonometric ratios to use or to solve for unknown side lengths. But today we're going to be seeing where you have the side lengths given to you and then you want to use the inverse functions or the inverse ratios to solve for the angle. So the inverse trigonometric ratios are when you raise the sine, cosine, and tangent to the power of -1. And now, instead of the input being the angle here, like it was with the trigonometric ratios, in the inverse, you are actually inputting the ratio there, which means that you are solving for these angles here. So, for example, if we want to solve for this theta here, you have to first determine which um, side lengths you are given and what the relationship is between those side lengths to that angle. Suppose we are given the opposite and the hypotenuse, then we know that's the case of sine because we have the ratio of opposite over hypotenuse. Now, that being said, because it's a right angle triangle, remember, as soon as you have two angles, or sorry, two side lengths, you can always use Pythagorean theorem to solve for the third side length. So really, you could use sine, cosine, or tangent in solving for theta here. So if you were to start with the sine, so we have opposite over hypotenuse, and you would take the inverse and you will get the angle. So for example, given the sine of theta is equal to 9 over 15, then we can solve for theta as the inverse sine of 9 over 15, and this will produce 37 degrees. And on your calculators, you should have a button that shows you, and usually it is the on top of the, or it is matched with the sine function. Wherever you see sine, cosine, and tangent, it should have a shift button that produces the inverse sine, inverse cosine, and inverse tangent. Or if you are using online calculators, you can just input it as sine and raise it to the power of -1 and then input your ratio to get that angle. So let's practice here. And again, now I highly recommend you use your calculator to practice getting these values. So here, if I want to solve for theta here, I'm taking the inverse of cosine of 12 over 20. So I just put it in my calculator. So I put inverse cosine and 12 over 20. And maybe I'll try to show you. This is what it looks like in my calculator. So we have the cosine inverse and then 12 over 20. And if I evaluate this, I will get 53 degrees. And I'll actually point out to you here that this is that 3, 4, 5 triangle here. So if you match it up, you should get 53 here because really this ratio is just the 3 over 5, which comes from that 3, 4, 5 triangle. Now in this next one, we have sine. So we take inverse sine of 18 over 30. And again, I'll show you on my calculator. So as you can see, I have the sine inverse and then 18 over 30. And if I evaluate this, I get 36. It's 36.9 degrees, or we can say approximately 37 degrees there. Now, next one, tangent or theta is going to be tangent inverse of 7.5 over 13. And you can definitely have decimals there as well. It will still produce the same answer. And as you can see here, I have my tan inverse and I get approximately, and I'll round this up because it's 29.98. So maybe 29.98. And then I'll write theta is approximately 30 degrees. And don't forget your degree symbols as well, because these now when you're solving for theta, you do have a unit because it's an angle as compared to the ratios which don't have units. Now, for application problems when it comes to trigonometric ratios, there are two common terminology that you should be familiar with, and it is angle of depression and angle of elevation. So angle of depression, so think of depression as going down, and this is the downward angle measured from an observer's horizontal line of sight to an object below. So consider a tower, and you are standing on top of the tower, and you see something, an object here. This is an object. So from the horizontal line here, you might see this object downwards here. And this will be the angle of depression here. Now, alternatively, we can have angle of elevation. So now, suppose you are standing on the ground, and on top of a tower, there's an object. Now, from where you're standing, if you are looking up, this is now elevation because it's going upward. So it is the vertical angle measured between a horizontal line of sight and an object. So again, consider if you're looking horizontal. And now when you're looking upwards, so the measure there is going upwards, whereas in this one, angle of depression, it's going downwards. Now, in our first example, we have a television has a diagonal measurement of 65 inches and a width of 56.5 inches. Determine the height of the screen. So with application problems, especially with geometry problems, always draw a diagram first and label your diagram so it helps you visualize, and it also helps whoever is reading your solution to visualize what you were thinking and help support your solution. So here we have our television. And of course, when you're drawing your diagrams, you don't need to have the actual television. It is sufficient if you just draw a rectangle because you know the television is a rectangular shape. And so in this case, we have the diagonal as 65 inches. We have the width as 56.5 inches, and we want to determine the height. So here we have a right angle triangle because it is a rectangle. So then we are using Pythagorean theorem. And recall that Pythagorean theorem is going to be a squared plus b squared plus c squared, where c is the hypotenuse, or the diagonal, or the longest side, or the side opposite to the 90-degree angle. And so here, depending on how you label it, so if we say that this is a plus b, or a squared plus b squared, and this is c, then we are solving for, in this case, either A or B would be an appropriate answer here, as long as you know we are not solving for C, which is the hypotenuse. So in this case, we can do 56.5 squared plus B, what did I live? Yeah, B squared is equal to 65 squared. And now B squared is going to be, and if I just evaluate each of these, so this is 4,225, and I can subtract and I'll evaluate this. So again, I am skipping a few steps in my solution here. This will be 3,192.25. And then b squared will be 1,032.75. And I'll just move over here. There we go. B is going to be the square root of 1032.75. And if I take that square root, I will get that B is approximately, and just one decimal point here is fine, 32.1. And my unit was, oh, so this is, sorry, I have to fix this. This should be inches because we were working with inches. So B is 32 inches. 32.1 inches. And remember, with word problems, you do have to have your concluding statement. So here, the height is approximately 32.1 inches. So when it comes to boxing your answer, it's actually better I box this one. And then I have my concluding sentence separate there. So you can see my solution, and then I have my concluding sentence, which is giving context to or which is interpreting the solution in the context of the problem, which was the height of the TV. Now, next problem here. A ski lift cable is 420 meters long and makes an angle of elevation of 32 degrees with the horizontal. Determine the horizontal distance from the bottom station to the top station, and we are told to round to the nearest meter. So consider this is the bottom station of the ski lift, this is the top station, and of course this is the horizontal distance between these two stations. And we are told that the angle of elevation, so remember, moving upward here, is 32 degrees, and that this hypotenuse here, which is the ski lift cable, is 420 meters. So here we have a right angle triangle with two sides that are unknown to us. We do have this hypotenuse and the angle, so we can use our trigonometric ratios here to find x. And again, we want to interpret these side lengths with respect to this angle. So of course, x here, which is what I need, is the adjacent side, and this is the hypotenuse. So it is best here if I use cosine, which gives me adjacent over hypotenuse. So here, that's exactly what is said here. We are using cosine. And so cosine of theta here is going to be adjacent over hypotenuse, which given our values, we have cosine of 32 degrees is equal to x over 420. And if we solve for x, we are doing cosine of 32 degrees times 420, which is approximately 356.18. And actually, I should have rounded here. So I'll keep this as my final answer here is meter, but then in my conclusion, because we were told to round to the nearest meter, I will say is approximately 356 meters. So the horizontal distance here from the bottom station to the top station is approximately 356 meters. Now, if you were also asked to find this vertical distance, you can also, or it could have been asked of how far up is the top station from the ground, and you can again use trigonometric ratios here. You can do sine with respect to opposite over hypotenuse, or now that you have x, you can use Pythagorean theorem. Now, one thing to keep in mind with that, if you do use Pythagorean theorem, if you have made an error with x by chance, using the value that you have solved for increases the risk of error in your final answer. Because again, if you made an error here, then you're going to follow through with that error here. However, if you use sine, even though it may be a little bit more challenging at this point to use trigonometric ratios compared to Pythagorean theorem, which you're more familiar with, but it does ensure a more precise answer because you're using the two givens from the question. And so your chance of error is lower because the two values that are given to you, you know for sure they are correct. So just one thing to keep in mind if you are if you have multi-part questions. Now, in this next example, we have a sailor observes the top of a lighthouse at an angle of elevation of 12 degrees. The lighthouse is 38 meters tall. How far is the boat from the base of the lighthouse? And here we are rounding to the nearest tenth of a meter. So here we do have to define our variable because we aren't told here. So again, you can draw your diagram, but it is also a good idea and good practice always to have your let statement. So let x represent the distance from the boat to the base of the lighthouse. And we can see it visually here as well. If we have our boat here and the lighthouse, x is the distance between them. And a sailor that's looking upward at this lighthouse has an angle of elevation of 12 degrees there. So we want to solve for x. And here, with respect to this angle, I have the adjacent side and I have the opposite side. So knowing I have adjacent and opposite, it is best for me to use tangent, which is, remember, TOA, opposite over adjacent. And substituting my values here, tangent of 12 degrees will be equal to 38 over x, which is our adjacent side. And now, if I want to solve for x, that is the same as 38 divided by tangent of 12. And x will give me 178.8 meters. And of course, we want our concluding sentence. So the distance between the boat and the base of the lighthouse is approximately, because we're not using the exact value, 178.8 meters. Okay? And that would be it for our solution. Now in this next one, we have the similar problem, but now with angle of depression, so you see what that looks like as well. So now an observer is standing on top of the lighthouse, and they spot a boat in the water at an angle of depression of 15 degrees. So consider when the person is standing at the lighthouse, their horizontal line of sight is right here for the observer because they're standing up here. So when they're looking at the boat, which is down on the water, they are actually looking downwards, which creates that angle of depression. And that's that 15 degrees we see here from this horizontal. And we are told the lighthouse is 60 meters tall, and we want to know how far, again, the boat is from the base of the lighthouse. Now, with this diagram here, as you can see, I don't actually right away have any of the angles except for the right angle or the right angle. I don't have either of these two angles within this triangle that's formed. But I do know that this is a 90-degree angle, so knowing that this is 15, I can find that this is 75 degrees. And so I can show that on the diagram there, and maybe just to show my work, I'll say 90 degrees minus 15 degrees is 75 degrees. And so that's why also diagrams are really helpful because they, instead of having to write this out, I can just label it on the diagram and it shows that I was able to find that angle as 75 degrees. Now, I do need a let statement here. So here, let x represent the distance from the boat to the lighthouse. So now I am solving for this x. I have this angle here and I have this side length. So again, with respect to this side length, the two sides that, or sorry, with respect to this angle, the two side lengths that I have and want are the opposite and adjacent. So this is also a case of tangent. So tangent of 75 degrees is going to be, remember, TOA opposite. So in this case, opposite is x over adjacent, which is 60, and this is meters. And now, solving for x, this is tangent of 75 degrees times 60, and if I evaluate this, I get x here is equal to 223.92, and this is approximately. And because I'm not told here what to round, two decimal places is always a good practice. So then I can say, therefore, the boat is approximately 223.92 meters away from the base of the lighthouse. And you can always choose how to word your concluding sentence. You don't have to follow the exact format of the question. You can play around with it, express your creativity there, and that would be our final answer there. Now here, Carmen has a triangle-shaped garden and she plans to plant with seeds. The garden is shaped as below, and we're asked how much it would cost her if the seeds cost $13.25 per square meter. So here, we want to actually find the area of this triangle because we want to know how many square meters is her garden and use that information to calculate the cost. So this is not a right angle triangle, so we cannot use the formula for the area of a triangle right away because if you remember, the area of a triangle is half of the base times height. However, in any way you rotate this garden, we don't have a height given to us. So we actually need to determine the height. There we go. Oh, sorry, minor correction there. It should actually be this angle, and you'll see now why. Because in order for us to draw the height now, so consider AC to be our base here. And so the height will be this line drawn here, which forms a right angle with the base, which will be our height. So now, with respect to this angle, we want to solve for this height here, and we have the hypotenuse, and this is the opposite side. So then, we can use sine. So then and let height here is equal to h. So sine of 40 degrees is going to be equal to h over 13, so opposite over hypotenuse. And that's exactly what we see here. Height over hypotenuse, h over 13. And solving for h, we have 13 times sine of 40 degrees, which is approximately 8.356 meters. And I can also solve for now the base here. And one more correction as well. You will later in the next lesson see how you can solve for this base, but as of right now, we don't have the tools to solve for the base. So assume the base is also given to us as 15.45 meters, but again, we still wouldn't have been able to solve for the area right away because we would have had to solve for this height. But now knowing this base, I can solve for the area. So remember, area is half of the base times the height. So in this case, 15.45 times, and the height was 8.36, let's say. And this is going to produce approximately 64.58 meters squared. And to calculate the cost, remember the cost is $13.25 $13.25 per square meter, which is going to produce. And here we definitely only keep 2 decimal points because we're talking about money. So it's 855.69. So $855.69. So it will cost Carmen approximately $855.69. And that will be the end of this problem. So again, I will have the diagram updated for you with that base, but we did need the base there to solve this problem. And okay, now with our last example here, a 9.2 meter ladder leans against the wall. The top of the ladder reaches 7.5 meters up the wall, and we want to determine this angle that the ladder makes with the ground. So with respect to this angle, the sides that we're given are opposite and hypotenuse. So sine of theta is going to be 7.5 over 9.2. So then theta is going to be the sine inverse of 7.5 over 9.2, and we get theta is equal to 54.6 degrees. And so don't forget your concluding sentence there. The angle the ladder makes with the ground is approximately 54.6 degrees.